So the first thing to know is that function notation is the same thing as a function, but it's different. The notation signifies that it's a function, and we use a little different language when we say it. So instead of it looking like y equals 4x minus 1, we write the function like this. It's the same thing. F of x is the words we're going to use for there. It's the same thing as y. F of x is the same thing as y. The way we read this, though, when we say it, is we say f of x equals 4x minus 1. So instead of saying y equals, we say f of x. Or you might hear people say the function of x. So f of x. What's going on here is f of x is our output, just like with our function y was our output, and x remains our input. So, I mean, nothing really changes on what's what in our equation. The x is the input. The y, also known now as f of x, that's the output. Okay? It's the same thing as y. So sometimes you'll see an xy table with an x and a y. Sometimes you'll see it as, I almost messed that up, x, f of x. These are the same thing. Same thing. Okay? And I know you're probably thinking, why do we have to have a new way to say something? You guys thinking that? Because it seems silly. Why don't we just rock y? I'll show you. You got to just wait for the back. Okay? So here's how it works. The function of x equals that stuff. So right here, that's saying, what happens if it's f of negative 7? Well, f of negative 7 in this circumstance just means 4 times negative 7 minus 1. Okay? It's the same. It's saying, what's the function of negative 7? Negative 7 would be our x value, our input. Our output is going to be the solution to this, or y, which is the same thing as f of x. So negative 28 minus 1, that means the function of negative 7 is negative 29. That would be our answer, but just for context, what that means is when x is negative 7, y is negative 29. That's like how our function works to pump out an ordered pair that we could then graph, right? I'm trying to make some connections to a couple days ago. Let's practice evaluating some functions. I'm going to do number 1. Y'all are going to try number 2. So, the f of x is x plus 7. So if I have f of 5, that's the same thing as 5 plus 7, right? My x value is 5. Let's find my y value. So when x is 5, y is 12. So f of 5 is 12. That's the answer. Again, just for context, that means when x is 5, y is 12. You don't need that. I'm just putting in context what this stuff's pumping out, because all functions are going to have graphs. We need to be able to use that representation at some point too. So you guys are going to now try out number 2 on your own. Don't worry, like if you're feeling like it's still a little funky, that's fine. Try something out. Do it lightly in pencil. We'll erase it. We'll fix it. We'll get better. For number 2, g of negative 3 is 3 times negative 3 minus 8. So g of negative 3 has to equal negative 17. So here's the reason for g. G of x is the same thing as f of x. They're just signifying that they're two different functions. So if we were working, let's say, with 5 different functions at once, and I just said y equals number, because all the functions had y, do you know which function that would go with? No. But if I have g of x equals number, do you know which function that y value goes with? Yes. So it's an organizational thing to differentiate between functions. So for some reason, you know how like a lot of times with variables it goes x, y, z? Like the 3 variables you use a lot of times are like x, y, z, or a, b, c. A lot of times with function notation, if you have one function, it's going to be f of x. If you have 2, there's going to be f of x and g of x. And you have 3, it's f of x, g of x, h of x. So I know it sounds crazy what I'm saying, right? But that's how that stays organized, f, g, h, the multiple functions. So it's how you know which function that y value goes with. It's an organizational strategy. I don't know if you ever heard me talk about this, but math is communication, so organization is important. Let's look at number 3. I'll do number 3. You guys got to do number 4. So you already did 3. So I'm going to substitute 9 in for x. So notice that I have an h function. If all these just said y equals, we don't know which function they're referencing necessarily. So I'm going to cross simplify here. I get a 1 and a 3. 6 minus 1 is 5. So what that's telling me is when x is 9, y is 5, that is 0.95 for this function. I know it goes with h function. Even if everything was scrambled up on this page, I know that this is the y value for this function because it's h of x. All right? If everything was just y equals, we wouldn't know what function it goes with necessarily. All right, I want y'all to try out number 4. All right, so there's the reveal. Make sure when you do negative 4 squared, it's in parentheses so it becomes positive. Yeah?
For future, like showing our work on like homework and tests, would it be
Yeah.
okay if I just immediately wrote 1
Yeah, I'm cool with that. Yeah.
4? Yeah.
They're interchangeable, right? So, yeah, I'll take that. All right, try out 5 on your own while I'm getting this ready, please. You guys ready for this wild ride? Here's how I'd substitute it in. Which gives me a negative 25, a positive 30, and a negative 4 for an answer of 1. So check it out. When we're looking at this term, that term is the opposite of x squared, right? So if x is 5, the opposite of 5 squared is negative 25. That doesn't mean it's a negative base. It's the opposite of whatever your base squared is. I know it's like week 1 when we did exponents, but it's tricky. I get that it's tricky. That's why I keep pointing it out to you. All right, trial number 6. Let's have you guys do 6, 7, 8 all at once, and then we'll review. 6, 7, 8. All right, for number 6, I'm looking at g of negative 8. So I'm going to substitute negative 8 in for x. So half of negative 8 is negative 4. Negative 4 plus 9 is 5. Okay, for number 7, I got a lot going on here. This is a quadratic function, in case you were wondering. It's Soldier Boy's favorite. Yep. Okay.
Why don't I get that?
It's probably a good thing you don't get it. All right. So, on this one, I have to square my negative 5 first. So negative 5 squared is 25 times 2 is 50. I got a 50, a negative 20, and a negative 9. So 30 minus 9 is 21. Okay. Some things I've seen there's like a 71 or a negative 71 that was wrong. If you did that, you multiplied first. Don't multiply first. Okay. And then g of negative 7. I get the absolute value of negative 7 minus negative 7 squared. So this one gets a little tricky. There's a lot going on, but no. So this is minus 49 right there.
Wait, but you wouldn't. Right, yeah.
You can't make it plus positive because you have to do your exponent first, right? So if g of negative 7 equals the absolute value of negative 56, the absolute value of negative 56 is positive 56. Okay. Well, fix the understanding, because if you get another one that's similar but different, you don't. Sometimes you'll accident into the right answer in math, but you want to have the right understanding, right? So, what did you guys notice about number 9 here in our template?
C plus.
Yeah, it's not a number, it's a C plus 7. I mean, it is a number. We just don't know what part of the number is. But if we have the understanding that it's f of that thing just gets substituted in for x. So, all I'm going to do is substitute that in for x, which is exactly what I did in all the previous problems, right? I'm not done yet, but do you guys see that this is it looks different. So if you're memorizing what do I do when it looks like this, you're going to be like, oh no, I haven't done this before. But if you're leaning on I'm substituting what into it for x, what the function's of, right? Then it's no different. I'm putting c plus 7 in for x. Okay? So I'm going to distribute. I mean, it's always been in an equation.
Well, okay, I'm sorry.
No, I'm not trying to be snarky. So I've got a 4c plus 39 would be my So if x is c plus 7, I know that y has to be 4c plus 39. I know it's not a super satisfying answer because it's not like 0.47 on a graph or something, right? But that is what it is. In order to actually graph it, we would have to know what c is. But what's cool is, guess what? What happens if c changes things? Well, it doesn't matter what c changes to. I can always put it in there and get an x and y. That's what's powerful about using variables. Okay, so try number 10 out on your own. It's similar. All right.
Yeah,
So,
I guarantee you would.
if I'm looking at h of 2k minus 5, Jack, what's going in for x?
Which one?
10.
I've already done all of them.
What's going in for x?
2K minus 5.
Negative?
What's
Knock out.
Hey, not an X.
2k minus 5?
Wait,
Okay.
that's actually what goes in, right?
That is a K.
That's going in for x. So the function h of 2k minus 5 is equal to negative 9 minus 2k plus 5.
Oh,
So I get a negative 2k minus 4. So h of 2k minus 5 is negative 2k minus.
Oh, I messed up.
Yeah, not a super satisfying answer, I get it. But again, I'm going to point you to the why it works. Because if you understand why the f of 4 works for the reason that it works, again, this is not different. And if you lean on understanding, right, in math, there could be like infinite different things thrown at you. So if you memorize it, good luck memorizing infinite things. But if you understand it, you can apply it to like lots of different situations that are similar, right? That's why I try to do that. So keep that in mind as we move on, because things are going to look different. So if you're trying to memorize what to do, it's different. But if I have f of 4, 4 goes in for what?
Well, we got into the second page yet.
Yeah. So if it's f of 4, what does 4 go in for? X. So my eyes here are going to go to there, right? So if x is 4, that means f of 4 is 8 minus 3 times 4, correct? Right? If f is 4, f of 4 is the same thing as 8 minus 3 times 4. So then I just need to add 9 to that.
I knew that.
Okay? So 8 minus 12 plus 9 is 5.
There's so many.
I know. So this is the reason for the f of stuff, because there's 3 different functions over here, right? You guys see that? F of x, g of x, h of x. If I just had y equals, how do I know which function that comes from? I wouldn't, because they're all just y, right? So the reason we don't use y is so when we have multiple functions, we know which ones our inputs and outputs reference. Does that make sense? Why we need to do this? Because I remember being in school like, just let me use a y. I know how to use a y, why do I have this? Well, the reason is we have multiple things we're referencing. We want to make sure we're referencing the correct thing. So, on number 12, I've got negative 2 times g of negative 5. So here's my negative 2. I'm going to multiply. Now g of negative 5, I'm looking right here. Negative 5 goes in for what letter? X. So I got negative 5 squared plus 2 times negative 5. That is g of negative 5, right? Negative 5 squared. Negative 5 squared plus 2 times negative 5. That is g of negative 5. Yeah, Max?
Wait, I'm just confused. What's the extra big parentheses?
Why is there a C?
Well, I have to have the whole thing. I put the whole thing in parentheses, right? And when I'm substituting in my negative 5, I have that in parentheses because it needs to be a negative 5.
Okay, I thought
Yeah,
that was the one.
I got parentheses in parentheses, baby.
Oh, I thought
Some
that
people
was
like to use brackets there. I just use
I was
multiple
thinking
parentheses.
puzzle.
Okay, so let's look inside the parentheses. Everybody seeing 25 and negative 10 up in there? There's 25. There's negative 10. So negative 2 times 15 is negative 30, right? We need to have our order of operations on point, correct? All right, number 13. What 2 things am I add together? G of 4 and G of negative 1. So G of 4 is 4 squared plus 2 times 4. Plus G of negative 1, which is negative 1 squared plus 2 times negative 1. It's the same, Jack, it's the same thing as this. Let's say you'd set over here. Let's say you solved G of 4, and you got 16. I forgot to put 4 there. Okay, what's the question? Well, I need to add these two things. I need to add the y value of that function plus the y value of that function. So g of 4 to get that y value would be that. G of negative 1 to get that y value, it'd be that. It'd be kind of like Jack doing this. I'm doing g of 4 equals 4 squared plus 2x, and I'm doing g of negative 1 equals negative 1 squared plus 2 times negative 1. I meant to make this a 4. I don't know why I keep doing that. Plus 2 times 4. Right? Like we were doing? Well, I'm just taking my g of 4 value and adding it to my g of negative 1 value. That's all this is. Okay. That helped? Okay, so I got 16 plus 8, which is 24, plus 1 plus negative 2, negative 1, for 23. You think that one was confusing. Why do you see this next one? But let's lean on knowledge, what we know.
Oh.
So, and this is the reason why. There's two different y answers, right? So we differentiate between our y answers from having h of and f of. So, I've got 3 times. H of 2, I'm looking over here. H of 2 means negative 5 halves times 2 minus 1. There's my h of 2. And I need to subtract an f of negative 9. So f of negative 9 is going to take me there. 8 minus 3 times negative 9. Okay? Then from here it's order of operations, which is, I know it's old news, but my 2's cross simplify. I got a negative 5 minus 1 for negative 6. Negative 6 times 3 is negative 18. Okay? Over here, I got a positive 27 and plus 8, which is 35. So minus 35 for a total of negative 53.
So is that the y value or the x value?
So this is just the value of the expression which has this y value and this y value in it.
Okay.
This is not an ordered pair. This is, an expression. Okay. So 15. 15's a little different. All the rest gave f of a number, right? This says f of x. So that what are we inputting into the equation in this case for 15? The x or y value. Which value do we know, the x or y on 15? We know the y. So if f of x is negative 13, that means negative 13 equals 8 minus 3x. So all the rest of them are given the x value, finding the y value, and this one we're given the y value, we're finding the x value. If we have an equation and you leave me one variable, I can solve for it, right? So once we're here, I'm going to cruise because this is just a two-stepper. Right? You guys can do some two-step equations all day. So my x value would be 7. So really what 15 is saying is, hey, if y is negative 13, what's x? X is 7. You have a similar pair. Here's what 16 is saying. If y is 39, what's x? So, if y is 39, what's x? You guys ready to go on this one? Add 1. We got negative 5 halves x equals 40. How do I get rid of that negative 5 halves? Yeah, multiply by negative 2/5. Which is the same thing as dividing by negative 5 halves, right? Now, cross simplify. I got a 1. I got an 8. For negative 16, baby. Some of us still need work on those fractions, but I mean we can't do that in algebra, right? Like, I'd love to do fraction stuff with you more, but you gotta have it. If you don't have it, come see me at Academic Help. We'll take care of it. We're gonna jump down to number 18 if you follow along on the template. These are my favorite because they're kind of simple. They don't look simple. I know you're looking at this saying, letters and graphs, what do I do? But if we lean on our knowledge that the f of x thing here, right? So what information is 18a giving me, the x or the y? It's giving me the x, right? Functions are f of x. So I know for f of negative 3, what's my x value? Yeah, so if I go to my negative 3 and then I look up here on my graph, what's my y value? When x is negative 3, what's y? 2. So f of negative 3 is 2. Okay, let's look at the function of 0. 0, is 0 my x or my y?
X.
It's my x, so I go up here and look at my y. I got 0, 1, 2, 3, 4, 5. So f of 0 is
Question got right today.
5. Okay, I'm going to the function of 1.
2.
No, 1. I knew what you meant. Okay? I'm going to go for the function of 2.
4.
It's
It's 2, negative 3. Okay, you guys try out number 19, and we'll get after it. All right, so for this one, when x is negative 4, y is 2. When x is 0, y is 0. When x is 2, y is negative 2. And when x is 5, right there, we got a negative 1. Cool, so I'm just going to throw that in there for fun. What is if f of x equal negative 2? That would give us our y value of negative 2, so I'd be looking right here. And when y is negative 2, x is more than one thing, actually. 2 and a number I can't tell, because it's not. There'd be 2 answers for that x value there. That's kind of fun. Cool. All right, guys. Your homework's on Go Formative. I got to open it up for you.